Thanks for joining us. Thanks for watching. And as always, hack on.
Heck on.
Sweet.
Wait, 1 second. Do you want to do the front roll where we ask him who he is and what his company is? 'Cause I don't think we ever mentioned Tulip Tree Tech.
We can if you would like.
then
Oh,
just
absolutely.
do that.
Absolutely.
We probably should do that.
Yeah.
What a great idea I've just had. How about we introduce Torvik in what in the world he actually does at the beginning of this video? Awesome. Well, Torvik, you're on the couch.
I'm
we
on the
just had
couch.
an awesome conversation. It's probably about that time where we actually hear who you are, where you work for, and we'll definitely throw this at the video.
At the
what
beginning
a
of the video.
brilliant idea I've just had.
Yeah, just cut it in, man. All right. Hi, I'm Torvik. I'm the founder of Tulip Tree Technology. I got my patch. It's on the wrong side. My patch right there. I can make more patches if people want. Maybe I should make more patches.
People love patches. You should
Yeah.
absolutely.
I have
had
a really
stickers
good
for a long
idea.
time, and it was like, okay, stickers, and then you have water bottle space.
I have a really good idea. You should make more patches.
what
okay.
a wonderful idea. if
That's
you
a great
patched
idea.
me.
But I'm the founder of Tulip Tree Technology. We are a firmware development process company. We came from offensive cybersecurity, and we are trying to make more secure devices, safer devices to use, trustworthy devices by actually working directly with the manufacturers.
We started a conversation last night, and I was like, no, let's sit down and let's have this conversation.
Let's do it.
Because I've had this struggle in my business too, which is anytime you mention cyber to engineers, not every time, but oftentimes it's not my job. And we hit on this similar note that we both have been struggling with, and you've started working through a solution of what works for you.
Yep.
It's either not your job or they go, oh, this person is here to kick my puppy. Please leave. Yeah.
Don't kick my puppy.
Please don't
So,
kick my puppy.
Let's just start with what was the problem you hit?
So I want to make devices trustworthy. Make devices trustworthy again. Can I? Is that a?
yeah, your cheese. No, that's good. I think good slogan.
And probably
Great slogan.
probably we need to start here is who are you?
I was
and
about to
why
say,
are you on my couch?
Are we doing an intro? Or why am I on your couch? So I am Torvik, former offensive cybersecurity, and came out of that industry to try to go and like, why are all these devices are so hackable? Like, how can we fix this? How can we make these devices more secure to use, more safe to use, more trustworthy? Like, whatever word you want to use, like, these shouldn't be as hackable as they are. So coming out, and then I initially started developing tools to find bugs faster. I was like, let's find the bugs faster. And it turns out when you get into the actual commercial market, they're not looking for bugs. If they find bugs, they have to fix them, which then costs them more money. And so they don't want to find the bugs. And there are tons of people who are already doing a great job of using static analysis to identify and find vulnerabilities, to keep track of them. But the problems that the actual makers of the devices have are not related to cybersecurity. They're much more related to what are their actual pressures. There's time to market, and how much it costs to actually develop and make these things, and how long it takes to get there. You know, you're talking to a guy a company that's making a vacuum cleaner, a lawnmower. That's what I was thinking about. You're talking about a lawnmower manufacturer. Like, they're not concerned about cybersecurity. They're like, well, so what? You got your lawnmower hacked. Who cares? Like, big whoop. You could just go buy another lawnmower, you know? So, like, cybersecurity is not on their radar, but that doesn't mean that they shouldn't make safe devices. So, trying to figure out what the actual problems are that the manufacturers are having, so that we can actually eliminate the bugs before it leaves the factory floor. Because as we're seeing with all this long-term stuff, like all these end days are still out there, and people are still getting hacked with things that are 5 years old. Why? Because updating these things is a pain in the neck. And then if we want to talk about hospitals, like, so many devices, how many do I have to update? You know, sometimes the manufacturers are actually recalling the devices back. Here, I'll send you a box of new devices. Just send me the ones you haven't used yet. Send those back to me, and I'll fix them here, and you can have new ones that are already
Sometimes
patched.
they have to be recertified, right? So, like,
Yeah.
updating the device is a risk. It could kill somebody if they don't get the update right, or it just becomes non-functional, and then you have
Non-functional,
Yeah.
and then now I don't have an MRI anymore. Thanks, guys.
And also, the argument is they're not easy to update. It's not like
Yeah.
a Windows system where it's like, oh, let's push an update to 1,000 devices.
Yeah, and Windows updates always are very successful, and they've never bricked anybody's computer.
Well, it's like most of them, it's like, okay, it's not like, oh, I'm going to just plug in a flash drive and do this thing and go through the interface.
Right.
They're kind of painful to update.
And then when you actually start to pull back all this stuff, you're like, oh, we'll just make them updatable. It's like, well, Is it who's responsible for the update? Is the company that made the device responsible for the update, or is the tech who's on the floor? And how big is this hospital? How many devices do they have? How many techs do they have? How many people can actually
we'll simplify
do
this? We'll do updates over the air, and you can just connect them to the internet.
Oh yeah, that's a great somebody asked me today.
You're hitting a ton of problems, and also we also go back to the purpose of the device is not to be secure.
Yeah,
it's to take an X-ray, to take an MRI, to do this thing. It's not meant to be. Its core function isn't to be secure. Its core function is to do the thing. And if it's never hooked up to the internet, does it really need to get updated? Is usually
it's got a serial port on it. Yeah, I plugged an Ethernet adapter into the serial port so I can get the data off of it easier.
Exactly. I want to spin back. How you've been coming to DEF CON for a while, and you've gone through a couple different iterations of, we'll say, things you do here.
So I actually have not been much of a DEF CON attendee over the course of my career. I was always the guy they left back at home to actually get work done.
We're all going to go to Vegas and drink. Would you mind having that pull request done by?
Yeah, no problem. We need these things figured out. Can you? We'll see you guys later. So this is only the second year I've been back. I was here back in 2008, back when I first kind of entered the industry and hung out and had a nice time, and then just kind of like.
Wow, they thought you were that big of a party crasher. They were like, he's not coming back. You had to start your own company so that you
start my own company. So then I can all right, fine. Now I'm allowed to come, guys. All right, I'm allowed to come.
No, you're coming into something really interesting though. It's not like, we're not just doing pen testing, we're not doing security testing. You're developing, I want to say a product.
Yeah.
You're developing a product to be able to,
would you call it a development platform?
Yeah. So, and that's what we've been trying to figure out. It's like, okay, how do we poison pill them? How do you change the water that they're drinking so that they're drinking the water that has the fluoride in it? Oh, sorry. Eating the salt, using the salt that has the iodine in it.
There you go.
That's so like, how do you get there? And then you have to create the actual product, and then you have to make it so that they use that instead of what they're already using, so that the product that they make then come out already secure by default. And so then we have learned so much over the past 4.5 years about the embedded system development process and just the market. And like, you start looking at tools, and then you even look at like, okay, who's actually writing the software? Okay. A lot of times it's design contract firms that are writing the software. They put a team together, they do a 6-month development sprint, and then they hand off the software and like, okay, see you guys. And then now the company that has their name on the outside of the box now has the software, but they didn't write it. And so like, okay, well, who's actually writing the software? And then they're responsible for securing it. And it's like...
And then also, there's no guarantee that company that wrote the software is even going to be there.
Because it's not. Yeah.
Because it's not.
Yeah, because a lot of times it's like the Avengers. They just bring them in together and then everybody goes back to their own life afterwards. It's like, it's very interesting, and it's very complicated to try to figure out how to actually solve this problem at the root, because what we're doing isn't working. Like we're adding security in the 11th hour, or when it's already on the floor. It's like Ford trying to fix the cars in the parking lot. Like that's what.
Well, we know they can't do that either. So,
and that was the problem. You saw these lemons in the 80s and 90s. They didn't fix them on the factory floor. They fixed them in the parking lot, and it's like it's too late. Like
I'm going to argue this though,
do it.
Because we've even hit this other point, which is you have. Let's just say it's a larger enterprise. You have a dedicated security team which has cybersecurity knowledge. They have pen testing knowledge, they have reverse engineering, they know how to do bug bounty, all of that. Like they know how to find bugs.
Yeah.
You have executives which have their overarching goal. Like again, we need to get cars out into people's hands. We need to get lawnmowers out into people's hands. And then you have engineers who we have built this thing to do a thing to fulfill the business objective, whether or not secure. Normally, things like websites, all of that, all three of these groups can work together pretty closely.
They're in alignment. Yeah,
but when
it can be.
If you're an engineer and you developed a black box, effectively, a SCADA system, industrial control system, a thing which has custom firmware, there is so much industry knowledge, I'll say, in that group, where cyber can look for a web server they don't know. Again, and it's not that they don't know. It's just a specialty. To get to this level, it's a specialty of a specialty of a specialty, and cyber is taught on broad spectrum.
Yeah.
Executives, same thing. They have their own agenda. And the thing that we started talking about was, do you, like, for any product that's going to help the engineer, which is under the banner of security, there is a huge amount of education that needs to go into it. And if you go through cybersecurity route and say it will help them with security, there's a significant amount of education to just teach them on how to use this platform. But just to get the platform up and running, you need the engineer almost to set it up.
Oh,
and
yeah.
I'll say one more thing before I hand it off, which is when I remember back in General Electric, we would get this black box. And the black box, all we had to do is get the engineer to put like a square wave in, and our job was to bring down the square wave.
Yeah.
But we had none of the knowledge to even get the square wave up and running, because it would require them pushing custom firmware. And we had a remarkable open line of communication where they were wanted to make their product better.
Yeah.
That doesn't exist at most companies.
Yep.
How have you been solving that problem?
So even me as a software developer, I don't do cybersecurity on my own software products. Like, security teams are actually like really bad at writing software.
They're some of the worst in terms of writing secure software in particular.
And I would argue
because it doesn't need to be.
If security is writing software, it goes a tenth of the speed than ever before.
Yeah.
Because they're trying to secure their stuff. Like, they're trying to secure it as they're building it. And it just doesn't
and everything
work.
is really a cost. And so it's really a cost benefit analysis. When you talk about the executive, they're looking at like, what is this going to cost and what's the value that it's going to get me? And when you come at it from cybersecurity, they're like, that's a cost center. That's just cost me more money. And I don't necessarily get any value out of that. You know, who's going to hack my lawnmower? Why do I care? Like, it's not going to,
Actually, I believe it goes, if the lawnmowers get hacked, what are the actuarial tables that tell me what this is going to cost me in liabilities? Is the actual conversation you have, which is like, this is a very interesting way to look at business at this level. I'm not sure where to start trying to solve this problem.
Yeah.
Right.
Because that's what they care about. And like, and if John Deere spends the extra time and money, makes a more expensive lawnmower, and then DeWalt makes a lawnmower, and they don't go through any of that process, DeWalt sells more lawnmowers. And maybe you never get hacked. Maybe like, and who cares? Like that. So the value, you've got to be able to prove the value. And when it comes to engineers, and you want to talk about cybersecurity, like, how long is it going to take to set up? What am I even setting up to actually provide some value? But what engineers understand are failing unit tests. That's what engineers understand. So that's where we're going. Like, what we're teaming up with some small businesses in the development space that they want to make sure that when they go to integrate their product, either with another product or with the outside world, that it doesn't just fall over. And they'll get there. They'll test it. They'll do that integration testing, and it'll take them 2 weeks. And it'll be like, oh, well, I've already written all the software. And the other guy that wrote the software, like, he's already fulfilled his part of the contract. So, like, he can't really help me with this. And we only have this one piece of hardware. So we want to eliminate that integration testing panic by doing fuzz testing. And it's like, oh, we can take a security solution product or a security technology that we develop for doing vulnerability research, and we can apply that to, we call it non-deterministic testing. So if you have a unit test, this is functional, this is deterministic. I provide this input, I get this output. Go. So what we do is we flip that around and we say, okay, let's provide random input and see what happens with the output. Let's say we expect this kind of output, and then let's give it a random input and make sure it happens. And if it crashes, or if it
doesn't return,
like any number of things, like, you can do that. So like, then what we do is we're like, okay, well, here's your failing test case. Got you. So then we create a deterministic test case from that and say, okay, here's your failing unit test case. Now you understand that. Fuzzing, for any reason, makes more secure software, because you are testing those boundaries that you didn't write a functional test for, because who's got time to write functional tests for all the possible edge cases that are out there?
Most of the ones I'm seeing functional edge cases. And then if the team is, we'll say, if the team is good, they have some level of unit tests.
If they're good, they have unit tests.
Yeah.
Like,
if they're great, they have security tests, which is,
right.
I expect these to pass. I am expecting this to successfully fail.
Yeah. Yes.
And then what you're saying is there's a next level,
right.
which is, now I have things I expect to be good, to pass, to successfully fail, and then ones that it just has to pass the gambit of this fuzzing.
Right. Here we go. We're going to run this fuzzer for 2 minutes. 2 minutes. We're on this fuzzer for 2 minutes, see how it goes.
And now, just see if it falls over dead,
just to see if it falls over.
Now, here's the question, is when you're designing those unit tests, it's going to fuzz for 2 minutes. Is it the same fuzzing tests? I'm going to say, like, here's a 2,000 tests going to run through in those 2 minutes. Is it the same 2,000 tests, everything, and then you create more unit tests to add additional time testing?
So no, that would be a deterministic test. So this is non-deterministic. So you have the random fuzzing, right? So like it is fuzzing in the sense of you start with some seed, you're generating some random output, but it's not that easy to integrate. I'm going to take over a little bit here. It's not that easy to integrate because this is some of my background. I wrote some of these frameworks in a prior life. You need, and to a certain extent, the engineers who understand these things to at least write what the payloads are going to look like. Just not
like a schema,
like the schema, whatever you want to say, but not what the contents are going to be. And then you add AFL or any classic fuzzer that you want that is just going to take some kind of feedback loop like branches and stuff like that and decide how to generate the next payload of that structure. But it's not going to be the same random input every time. But you don't want that. That becomes a deterministic test. You can just go green or red based on this 1,000 set of inputs, but a set of 1,000 inputs when their actual space is 500 billion isn't particularly useful unless you select them randomly.
Yeah.
No, it's not deterministic.
If it's not deterministic,
yeah,
and it's a CI/CD pipeline, which is this, I'm going to push this PR. And if it passes all the tests, it's going to get merged in.
Yep.
Because it's non-deterministic, that means you might do that PR, it won't pass.
It won't pass.
You're going to resubmit the PR.
Yep.
And if it's now different, it might pass.
Correct.
Yeah,
absolutely.
Correct.
I mean, but the idea is that now we found an edge case. We can create a unit test for that will fail every time now.
That is cool.
And that's
all of a
because
sudden,
we have the input. We have the input, so now I can actually create a deterministic unit test based on the input that I did. Like here.
All I could think of is a script which
you just try it again. Try it again.
Submit. Okay, it didn't work. Let's just try again.
Yeah.
That one didn't go through. Just keep resubmitting until it eventually passes, and we're good.
Yeah.
So in this case, what your building does, it fuzzes it, finds the failure input, and feeds it back. Now
we can create a test, and now you can actually, and then, hold on. We're doing AI to create a patch then, and then rerun the test to actually go and actually pass it now, show that we've actually succeeded in doing it.
Have you created, when it creates PRs, because we hit this, and again, this is a prior life, is the fuzzing, like we'll say, if they're set requests, it wasn't one request that caused the failure. It was the combination of these three and then this one.
Yep.
So in that failure case, is the tool smart enough to be able to go, okay, we tried to create a new unit test here, but that one succeeded. So now try the past two patches.
Yeah.
Did that one fail? Or will it actually create the failing test?
So we're working on building this out. So this is still pretty new. We're still pretty early on in the process of building this out because what we've done is we've kind of stopped work. We've stopped work on what we were working on before, and we've gone directly to the manufacturers and just sat down and talked with a bunch of them and be like, tell me about your process. Tell me about what you care about. And when you start to listen to them and understand what their actual problems are and what their motivations are and what value they're being held to, then I can understand, like, okay, so we can build this. So we're really early on still, and I've got some excitement built up behind it. But of course, you got to deliver on the tech. And sorry about tech guys, but when it comes to running a business,
you're not yourself a tech guy.
Don't talk to me. Don't talk to me from 5 years ago. But when the hard part is not the technical work. The hard part is finding the right problem to apply your technical expertise to.
I often say, even in my current position, everyone has this idea that software development is all math and hard math.
Yeah.
It's like, no, the 90% of the problem is communication.
Yeah.
Just understanding what the hell somebody else wants or needs is 90% of the problem. The code writes itself after that. To an extent.
I know.
So now you just, pop up ChatGPT and plug a cable in and it dumps out all the codes, right?
I mean,
just vibe code.
I have kind of chastised my team. Like, you guys keep proving me right. You keep solving these really difficult problems to solve using engineering. Like, amazing. But you aren't able to solve the, who cares that you actually did this? And so we are embedding ourselves directly with manufacturers to actually do this. And so, coming to DEF CON is fun. but my customers aren't here because my customers are at embedded conferences. My customers are doing embedded development and not caring at all about security. And it's like I kind of want to like show them some of the stuff that's here, but I also don't want to scare them away from talking to me.
Well, and I think that's where I think you have such an interesting take on it, is going to engineers to say, I can help find those edge cases that you're worried about. And it's funny because like you don't call them vulnerabilities, call them bugs, call them defects. Don't call them vulnerabilities because they're really just edge cases.
They are.
We treat them
because
as
what is a vulnerability? It's just like, oh, it's not supposed to do that. Yeah.
You said
I have a vulnerability or a bug in general is when the expectation of the developer does not meet the reality of the code.
Correct.
It's just that simple.
We're just trying to find those, and we're trying to find them early enough in the development process that it's not a pain to fix. You start talking about like, hey, I developed, here's this black box. Now I got to go fix it. Like, oh my gosh. And then that's when you start to see the cost benefit analysis. Like, oh, we did the security scan in the 11th hour. How much is it going to cost me to go back and fix that? Oh, well, that's going to cost me a lot. Okay, well, let's delete this report and pretend like we never got it. Oh, let's make it so they don't actually email us the PDF of the report and they just read it out loud to us in a room. Only over that's what ends up happening.
And for most of these vulnerabilities, that's the thing, is every time I used to hear that, it was like, oh, how much does it actually cost in production? Web vulnerabilities, SQL injection, fix one line of code, what they do. We're talking about like firmware vulnerabilities, ones that are pushed out.
Restructure your project in order to make sure you don't end up in that loop. Like you might have to restructure how you're doing things just to avoid that situation.
So what is the core of the technology you've been working on? What is that platform? Is it like emulation? Is it like, because you're talking to manufacturers, presumably you're trying to get into the process before they even have sample hardware, so that they can start the development process and change the way they do that work from the get-go. What is it you are building?
So, and when you start looking at the embedded development space too, it's just a huge range of abilities and skill sets of backgrounds. You got people that come from some traditional software engineering, even universities. You got people who are just electrical engineers who have been writing software on the side for fun. And so it's this huge range of kind of like where their priorities have historically been and what they care about and what they understand and what they know. Then you also get the different board manufacturers that come with different, here's my board support package, here's my STM cube. Oh, well, you have to use this and this and this in order to get this to work at all. Oh, well, you're an ESP chip. Okay, so we only use ESP chip. Oh, we're using Texas Instruments. Oh, okay, we'll go to Code Composer. Which version of Code Like, so the development environment is also a huge mess. Like, there's just so many moving parts.
In the most traditional form, like, it is a bunch of hackers just making things work.
Yeah. And then you're like,
ostensibly.
And then the cybersecurity guy's like, oh, your stuff sucks. You guys can't secure it at all. Like, look, I can hack it. It's like, they don't care. Like,
they're like, yes, but it cuts the grass.
Yeah.
So fuck you. Right?
Do you know how much effort I had to make it so they cut the grass right? Like, and it slows down and speeds up. Like, it's amazing. It's amazing. Yes. So,
and just to be clear, it is amazing.
I mean, I think the industry has moved on a little bit from, we'll call it the security Neanderthal, who would come in at the zero on and be like, oh, hold on. We need to pause development. And we need a stable environment for 2 weeks while we test it. Like that, I know it still exists, but I think it's mostly gone away. Because I think at some point, cyber kind of looked over at what developers were doing and going, wow, they have a very elegant process. They have Git repositories, there's Subversion or whatever.
It's not across the board.
It's not across the board. But I mean, there's some process here. There's CI/CD. We have environments which can get spun up and spun down. I can spin up another environment over here to test. So like, I think security has evolved a little bit, but it is still interesting how like there's whole segments of industries, whether it's manufacturing tends to be pretty weak on cybersecurity.
Well, and they lag behind even in the development arts. Like, you're talking about a lot of the stuff that, like, modern software development. Like, a lot of teams still don't use modern software development. You know, I've talked with teams that don't even have Git repositories. They just have directories, and then they zip up that directory and email it to their customer, and then they're done. Like,
I mean, Linux still gets developed on the mailing list, right? Patches get emailed.
Yeah.
Which I will say, this is what I do now. It works. And for a distributed project, there's not a better solution. No one's come up with a better solution for that distributed of a project. But a lot of it goes on literally, you're expected to test your code. You're expected to it not be stupid. You're expected to make it public, all these things.
Kernel fuzzing,
right? And you're doing kernel fuzzing, all that stuff. But it still goes through this, a lot of people expect someone else to do the kernel fuzzing, right? Which is how it actually works. Your stuff gets pulled in, and someone at Google, I saw the new pull request, and they're going to run the tests that show that, okay, there's no new, random crash in this.
Yeah.
But there's still this expectation that someone else is going to do the security.
Yeah.
I would argue, though, like the reason that isn't that elegant of a process, though, is because it's remarkably fraternal. There's not that many kernel developers.
There's not that many people who want to be kernel developers.
Yeah, pass.
That's also fair, but I mean, like that's why that type of system works.
Yeah.
Where I think like you have.
I think depending on who you talk to, a lot of people would say they would not necessarily agree that it works. Depends who you talk to.
I think the thing which is forgotten so often is within larger companies, they didn't start off as an enterprise. Like most companies don't start off as enterprise. They start with 2 guys in a basement where all the code exists on this person, just like HR doesn't always exist. It's like, oh, well, if you need something, just go down the office, grab it, and come back. It's only one person coding on their local system, so why do I need
all this other stuff,
all this process and CI/CD?
And so yeah, well, and that's kind of like this, and that happens a lot, and because even experience, people with 30 years of experience doing embedded development, that's still how they work, because they're not used to working on a team because they have needed to, and so you're trying to find the people in this space, and so what we're focused on the people in this space who have already adopted a lot of modern software development techniques. You talk about the product I'm developing, like I'm calling it software in the loop fuzzing. So they do hardware in the loop testing, they do software in the loop testing. Emulator in the loop is the long term. We've talked about that a lot, not time today. But software in the loop testing, where I compile it for x86 and run it on my desktop. So if you can abstract the hardware enough away and then use your business logic, unit test for that, do that all in software, that's amazing. And not every team is like that. A lot of teams are still like, okay, I have a dev board and I'm just going to write it and not separate those layers out. And so we've had to been very specific about who we're partnering with to find the people who are ready for this kind of technology, because they're already doing things modern software. And so we actually looked at okay, maybe we should work on an actual embedded modern software development environment. And it's like, we are not the people that are ready, that can help with that. There are other people who are much more familiar with this environment than we are.
There are people trying that, but no one, the way I'd put it is, no one's undertaking the VS Code of embedded development.
There are folks that are...
There are people trying to do it, but no one's cracked it yet, because the platforms themselves trying to abstract it away is so diverse. It's just an impossible problem.
Yeah.
I wouldn't say it's impossible. It's just really, really hard.
And then real developers I don't use platform IO. Come on, that's for kids that don't know what they're doing. I don't use Arduino. That's for kids that don't know what they're doing. And it's oh my God.
Fast forward, everything's in Arduino.
So I've met professionals who do. They write stuff in Arduino because it works.
It works.
And so you're like, so maybe I should integrate this with the Arduino. So it's about finding out where we're going to fit, and we've got a few people on
So I'm going to spin this up, because most people watching this is going to be in the cyber field. They're not engineers. They're not going to be the ones who fix it. So what advice would you give to someone, we'll say, working in cyber, to help introduce these type of concepts to engineers?
It's understanding so what is the actual problem you're trying to solve. And I used to do this at when I was still with Ray. I used to do this with them all the time. It's what is the problem you're actually trying to solve? Is what you're doing actually going to solve that problem? If you're just trying to find a bug and then claim a bug bounty, great, that's awesome. Is that making the devices more secure? So we want to make the devices that come off the factory floor more secure by default, so that you don't have to update it as frequently. You don't have to worry about, I want them to be updatable by default, of course. I want them to have rotating keys for things, of course. But I want them to come off the factory floor already hardened. And so I can go and find bugs, and I can go into a company and be like, I found O-days on your thing. That's not going to solve the problem. If I'm talking and if you're dealing with even if you're dealing with the customer and you're talking to the security team, understand that the security team's over here, the development team's over here, and they're in a boxing match, and the development team is bigger and has longer reach. And so you're dealing with the security team
in more money typically.
And yeah, absolutely. And so it's so the security team would love to do what you want them to do, but they have to deal with the internal politics and deal with the development team and deal with the executives. And that's where we've ended up. It's okay, the people actually writing the software, those are the people we need to talk to. Those are the people we need to deal with. And so that's where our focus is. And I think there's a lot of people that kind of get stuck on that security. Like, we're a security company, so we have to talk to the security team. And like, I would argue, I would encourage anybody who can to like go figure out what it means to write these systems. Go figure out what it means to create these kinds of systems, and then figure out how would you do it. You're so smart. How would you do it? You're going to go write an ESP32 application. Great. How would you do cybersecurity for that ESP32 application that you just wrote? I just made a badge. Great. What kind of fuzzing did you do for your badge development to make sure that it worked and integrated? Were you up until, 3 o'clock this morning fixing all your badges?
Yes.
We
have a lot of history in that space.
No,
did you do something that made it so that you found those edge cases earlier on in your development process?
Oh, buddy, I have stories.
Oh, yeah. It definitely didn't involve reflashing, 3,000 badges?
At 2 a.m. in the morning.
But I mean, come on. So then...
That was
So
us, just to be clear, that was us learning our over-the-air update system crashed the badge when you tried to use
Which
it.
we definitely did not need to be needed that year, but we had it if we needed it. So,
Right.
But it sounds like the advice you would give to security who is trying to do something similar, is to get in with manufacturing, is not to go, here is the security process
Right.
we expect you to follow, but what is your existing process that you have in place? Okay, here's how security can help in some of these areas.
Right. How can we
here's
provide value?
How we can integrate.
Yeah.
You have this unit testing. Great. We'll meet you where you are. And it sounds so grandiose, but let's find out where you are, and we will meet you where you are.
Yeah.
We're not expecting you to come to us.
Yeah. And I want to be clear, like a lot of the stuff that providing actual security to making these devices less hackable is really boring. It's like, why did you write your own linked list? You're writing in C++. Just use S. You want to do secure C++ coding. Let me go to this class. Secure C++ coding. Use STL. Plunk. Bye, guys. So it's really boring when you come to the actual solutions for these things. But it's good hygiene.
So we shouldn't be writing our own ciphers.
Stop
and
rolling your own
algorithms.
crypto. At the same time, you have to understand that the people who are making these devices, they have requirements from their downstream customers to provide some sort, even like with an SBOM. So you have to decide, okay, well, I want to use this third-party library to do my crypto, but then, but it's made in Ukraine.
Or
so now I have
SBOM software bill of materials.
yeah,
software bill of
or
materials.
it's GPL2 and you're trying to keep everything closed source, or which make everything open source. Make everything open source. But sometimes you have license incompatibilities and your business wouldn't exist if
Right.
you didn't have that. So you just end up having to go rewrite some of these.
Exactly.
And so you have
understand that.
constraints. Yeah.
And so once you understand that there are constraints that have come out there that have nothing to do with don't roll your own crypto, duh. It's yeah, but there are constraints that I can't use this library, or this one wouldn't fit because I only have so much space and I couldn't recompile it and so I just wrote it myself. But if you have adequate testing and you have non-deterministic testing, then you can even write your own and feel pretty safe and comfortable that you actually did a good job.
So now that we've solved every problem there is,
Checks
In-
go.
in
Here's
all
my Zelle. Send me
of
my Zelle.
cybersecurity.
DEFCON 34 is canceled.
DEFCON 34 is canceled.
Yeah, sorry guys.
Well, Torvik, thank you so much for joining us. Is there any parting thoughts that you're I forgot one thing, and this is what I need to mention?
No, this has been great. I appreciate you guys chatting with me. This is a wonderful time. Love the
Awesome.
couches.
Well,
The lights.
they are comfortable. To pop a squat in the middle of DEF CON is quite nice. And I know all of us are looking as people are flying back and forth. So with that, though, thank you so much. Thanks for joining us. Thanks for watching. And as always, hack on.
Heck on.
Sweet.